Light does some interesting stuff, moving in a straight line or radiating in all directions or changing directions at a new medium or spreading out around two openings or one. Huygens explains it all. Consider this light source. If it grows enough, it will begin to look like that. A plane wave, crest, trough, wavelength, and familiar equations. So picture this photon as a wave front and wavelets growing at the wave speed. One period later, wavelets with constructive interference, and it happens again and again and again. Want a shorter wavelength? That's a higher frequency, a shorter period, less time for the wavelets to grow before we do it again and again and again. Again, these are wavelets growing at wave speed. Here's the good part. What happens if we double the number of wavelets? Well, let's see. It looks the same. Wavelets are free. Have as many as you'd like, and those wave fronts are unaffected. Whether your wave is a plane wave or a sphere, same wavelets growing every period, same constructive interference, and if you want more wavelets, they're all yours. Now do refraction, and I can't outdo this applet. Notice the plane wave is entering a new medium. We have the same circles there, only they're growing slower now with a new speed and a new wavelength and a new direction, but the frequency stays the same. This is Huygens' principle. So I hope you can agree that two-slit diffraction is less mysterious. We have plane waves over here, and then they spread out, but they're really always spreading out because of what we said before. It's constructive interference. It is all thanks to Huygens, which might seem kind of cool, but also kind of not totally necessary until you are faced with single-slit diffraction, because this picture makes no sense. At least it makes no sense to me. Why the central maximum? And why those dark lines with the same equation, but the equation gives the dark lines now instead of the bright lines? The answer is wavelets. At that same angle, we had constructive interference here, but that was only with those waves. More wavelets gives us destructive interference here, 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 and there, and you get the point. It's a dark band. And that is the point. Whether it's a laser pointer, a candle, or a pencil, it's all thanks to Huygens.